Welcome everybody. How's everybody enjoying the last day of DevOps so far? Yeah, it's kind of sad it's almost over. They go so quickly. Welcome to the talk. I'm David Blevins. I've been participating in EE for a while, about 10 years on the JCP, maybe 15 implementing various open source EE things. And so I think that the reason I put this together, this talk, and I want to make a disclaimer, there's no possible talk that could cover all of the things that have happened over the last 10 years of Java EE. So there's going to be some things that you're going to walk away and go, oh, why didn't he mention this or that, the other thing? And it's because it's just completely impossible to do that in 50 minutes. So the thing I kind of wanted to focus on in this talk is sort of when we do presentations about technology, we tend to focus on the latest specification and what API methods have been added or changed, and it's always so very zoomed in. And so I kind of wanted to give a bigger picture of what we've been doing over the last 10 years, just at the high level, and maybe kind of see if we can look at the reasons that we got here, how we are, where we need to go next, and just sort of the very, very big picture. Of course, there's a lot of technology in there, but yeah, trying to show the whole elephant. I don't know if anyone's familiar with that little story where people are trying to figure out what an elephant is, and there's like 4 blind people, and one of them touches the ear and goes, an elephant looks like a leaf. Another one touches the foot and says, the elephant looks like a trunk. A tree trunk. And so they all have completely different perspectives because they only have the one thing. So this is really sort of to try and see the whole elephant for a little bit. We won't get through all this material, but basically I'd like to show sort of a past, present, future perspective of the platform. So I guess it's a little Dickens in that regard. Okay. So first, let me just ask the question. So who uses EE in the room? Okay, the majority of the hands. Who's used EE since just one? Okay, let's go early, way back. Let's go like 1.4. Okay, all right. 1.5. 6. More hands. All right, and then I guess 7. All right, we have some good groups in here. Okay. So for those of you who are in the 1.5 kind of 1.4 era, there's a couple highlights that I usually find. Whenever I hear someone say J2EE, kind of like my ears prick up, and I think we need to have a discussion because you probably may have missed some things. And so one of the major things is, of course, annotations. So I hear a lot of people say in the same breath things like, this technology, that technology, EJB sucks, for example. There's a very common one. And certainly there are horrible things that are in there. But I always like to ask the question, do you like annotations in Java? And people say, well, of course I do. It's like, well, then thank you very much. They came from the EJB spec, basically. There was this thing that was around in the early 2000s. It was called xDoclet, and it was designed basically to. It was a JavaDoc processor that would read all the JavaDoc annotations and then generate XML from it, so that way you didn't have to deal with all the CMP entity bean mappings separately. You could actually do that in code, and so somewhere around. Just about after EE 1.4, they were kind of getting together in the room and said, what can we do? Think big to really make this stuff digestible. And someone sort of sheepishly raised their hand and said, well, there's this project called xDoclet. What if we made that part of the language or did something with that so people didn't have to deal with the XML complexity? So that's where annotations came from, and that's why they look like JavaDoc annotations, because they're really just inspired by this one project, xDoclet, whom we should all know this name. But anyway, it's a nice little bit of history there. So annotations came from sort of mistakes that we made, or rather I should say shortcomings that we were dealing with in Java Enterprise in the early sections. Another one is that's changed since the J2EE days is ears. There's no longer the need for ears too much anymore. You can take everything and pack it straight into the WAR file, and it's pretty much replaced this concept of what I call the Russian doll packaging. That was a really horrible aspect of early EE, which if you wanted to use EJBs and servlets, you basically, you'd be doing fine with servlets in your web app, and then the second you wanted to add an EJB, you'd have to now make an EJB jar, which had to be next to the WAR file, and then the whole thing would be wrapped up inside of another jar file, which was an ear. So you have like a jar file within a jar file within a jar file, and it's just really, really, really insane. That also added class loader complexity. So there actually is a class loader hierarchy, which is very ill-defined for ear files, and it is a bit of a portability problem. So basically, we flattened everything out, and everything can go on the WAR file now. So that's a significant change. Web profile. This is an interesting one. Who has heard of the web profile in the room? Okay, so we have about half. So for the other half of the room, you know how people would say that JavaEE is big and bloated? Yeah, well, they're kind of correct, because you can't add something year after year or version after version and never remove anything and not have it build up a critical mass of legacy. And so basically what we decided to do in EE6 is we decided to create the web profile, which is basically cuts JavaEE in half. And so the web profile is the kind of greatest current hits of EE. And it has the good stuff like JPA and JAX-RS and the CDI, and not some things like JAX-WS or JMS. JMS is good, but you don't need it for every situation. And JAX-WS is awesome, but probably you don't need it and REST at the same time. And so there's certain things that are not in the web profile. Who's ever used JAX-RPC? Okay, I always get like 2 hands in the room, so I salute you too. I had to implement it, so I didn't enjoy it at all. No one uses it, no one should use it, but it's still in the platform for backwards compatibility reasons. And that's one of the examples of things that are cut out with the web profile and the things that weigh down the platform. Corba, who's writing some new Corba apps these days? New? Okay. So aside from the 2 people in the room who use Corba and the 1 person who's still using Corba, I'd again salute. Binary compatibility is a very hard thing. Yeah, so Corba is also one of the things that's still in the full profile, actually still today. So JAX-RPC was made optional in EE7, but Corba slipped through and is still part of the full EE profile. So that really makes the web profile very significant. So basically, if you have something that's half of EE, that's a very major change. So that made possible a lot of people to do smaller implementations. And like I say, we've also now started to trim the full profile itself. So things like CMP entity beans now are optional in the full profile. Optional is a fancy way of saying, deprecate it, don't have to use it. We're not going to require the industries to support it. It's about the nicest way to exit something from, it's like if you bring someone to your office, like, we're sorry, Joe, you are now being made optional. You can stay, we won't pay you. So yeah, so CMP is optional, JAX-RPC is optional, and maybe we might make Corba optional, but we are trying to deal with legacy in EE, and that's a good thing to know. All right. So some of the neat things which I think are not discussed or very well known, we actually have in EE some sort of various forms of embedded concepts. So here, let me grab this. So in EE6, we added an embedded EJB container. Let me close this. Here we go. So the concept of we have this little project. This module is just one little project. And So basically, this is very much like JPA. It's very much a bootstrapping API. So there it is right there. You say EJB container, create container. You can optionally pass in some methods, a map of properties. And this is basically taken from some projects like OpenEJB that had done embedded versions of EJB since the beginning, right? And so the bootstrapping technique there was to do a new initial context and then pass in properties to the initial context, and then you would get an embedded container. And that was very much inspired by embedded databases, which would do the bootstrapping based upon the properties that you passed into the driver manager when you asked for the driver. And so that's where that bootstrapping API came from. We got this into the specification in EE6. And so here we have a basic unit test. We mostly bootstrap the container. We can call, add, subtract, multiply, divide, and remainder on our little stateless bean, which has, some very simple methods here. very non-fancy. So we can go ahead and run this. There we go. So we're in about 2 seconds. So who thinks that this matches the EE that you hear about? Who thinks this is significantly different than what you typically hear on a regular basis? Yeah, I mean, most people are trained to hear that this stuff is big and ugly and heavy and cumbersome and impossible to deal with and can't be used in a Java SE VM. And why do people need app servers anymore when they can just run everything in SE? It's like, yeah, we wholeheartedly agree, which is why we're trying to get this more and more into the spec. And, I'm a big believer that APIs are one thing and functionality is one thing. How you deploy it is your business. So EE started out saying you have to build a jar file, a WAR file, and put it in the app server. But the reverse is totally legitimate as well. What if you want to put the app server into the app and just kind of make one big ball? That's absolutely valid. It doesn't suddenly mean that you shouldn't be able to use things like JAX-RS or transactions or JPA. It just means you have a different style of bundling your application together, and it is a totally valid one. So there's a neat little thing that this is all fully standard version. So we have a little sort of non-standard extended version. So we have a little project here where I have a little REST service called microservice, very fancy, and I'm just going to return a list of string. It's got some basic, data in it, and then we have a nice little test case, and then we're going to go and actually with this one, we're going to use the Maven Shade plugin. And we're going to make ourselves an Uber jar. So I'll take a look. I'll show you the POM. So there we are. That's the little bit of magical Maven goo that will create us a nice little Uber jar via the Maven Shade plugin. So with that built, we can basically go so we're executing a fat jar, and then we've booted a server up, and we can actually go to this location, pop it open to a browser. And there we go. We have some JSON. And so that booted like pretty quickly. The jar size is I don't know, it's maybe about 25 meg maybe. Yeah, 27. So who would think that this would be an awesome thing to have standardly in the EE platform? And we're all trying to do microservices pretty much every day. We got a project that has effectively one class and a main that calls the embedded container and then just blocks so the VM doesn't exit. And we're basically doing a microservice with two classes and no third-party libraries other than the container itself. I mean, who would want to see this be standardized? Of course, that's like the whole room. So here is where I segue into an important topic. So who's heard of the Java community process? Okay, that's like 60% of the hands. It should be 100% of the hands. So the Java community process is where our standards come from. It's the farm that makes the food we eat. And there are a lot of people working on the farm. And this is now an open farm. This used to be a closed type of thing. All the standards like JAX-RS, JPA, EJB, CDI, everything come from the JCP. And it's a standards body, and these JSRs enter the JCP. An expert group is formed around them. You all work on this spec until it's basically complete. You get your ideas in, you hammer them out, you steam them out. And what comes out the other side is a standard that we all get to enjoy. So here's the significant thing. There's been some major changes in the JCP over the last 10 years. Let's put it this way. We've had open source EE for a very long time, since like the early 2000s. JBoss has been around for quite a long time. We didn't actually have certified open source EE implementations until 2004. So that was the first time we saw our first certified open source implementation. So basically, 2004, Apache Geronimo was formed. It was like 2003. Apache worked with Sun to get them to give the open source communities EE TCKs. So basically, Geronimo, JBoss, and Jonas all got TCKs. And that's when we first saw our very first actually certified EE implementations. This was just in 2004. So somewhere after that, we actually had now the open source vendors were actually allowed to participate in this closed group, which was the JCP. So then we had people like Gavin King getting involved and then helping to create JPA from Hibernate, and these types of things that didn't exist, that never happened prior to 2004. In 2004, before, it was all only closed source vendors forming the technologies that became EE. And a lot of the very bad reputation that Java EE has is from carryover from that era. Not that proprietary vendors are in any way evil, it's just you need to have a diverse set of community to create a diverse solution. So we had actual open source enter EE only as freshly as 2004. That was basically 10 years ago or 11 years ago from today. So then in 2009, we actually had our first open source specifications come out of the JCP. So prior to that, everything was closed, all the reference, so in 2009, CDI and bean validation and @inject were added to the EE platform, and they were the first technologies developed completely openly from the beginning in a spec group that was using like Apache licensed RI and Apache licensed TCK. So this is very, very significant. So this is basically the first time we've seen open TCK that anybody could run against the implementation. And it's very significant change. 2011, we hit another milestone in the JCP. That was the very first time that spec groups were required, per the new JCP process, all JSRs have to be open as of 2011. That's not too far in the past. So prior to that, you had to be invited in. And not only did you have to be invited in, once you were in, you had to basically sign an NDA saying you're not going to disclose anything that's happening in the expert group. So if someone wanted to say, oh, I don't like to implement this because we don't it doesn't fit our platform, and everybody else says, yeah, we do, you couldn't expose that debate publicly. You couldn't say, well, it might not happen because this vendor doesn't want it in, or something like that. That was totally legitimate, and these things happened. So as of 2011, all the smoke-filled rooms are cleared, and we're all sitting in a glass room with glass walls, and in fact, now the door is open. You can actually enter the room, and you can actually get involved, and that's a very significant thing. So actually, EE7, released in 2013, was the very first version of JavaEE developed completely openly. It's a very interesting thing. So I like to summarize with this. Basically, in the past, we had 70% of the implementations we had open, but documentation, maybe 5% of it was open, and 0% of the TCKs were open. Currently, we have maybe 5% of the TCKs which are open, CDI and bean validation, but we really need a lot more. Documentation, we're starting to see more projects use things like ASCII Doctor for their actual specifications, their actual text. That's an improvement because a lot of this stuff is held in FrameMaker files that only the spec lead gets to see, and so you can't actually contribute text to the specification so easily. So we're actually opening up this process. Of course, in the future, I hope it's 100% open, top to bottom. I think the significant thing about TCKs being open is you need to think about it this way. So a lot of people look at EE and they feel like it's restrictions upon them. They feel like when they read 2,000 pages of PDF of requirements, that this is a burden upon them and that they feel like they're being put in a box and constrained. The reverse is true. The vendor is actually the constrained one, and we all have to do things according to a very specific set of requirements. The vendor is the constrained one. If you were actually able to contribute a test to the EE-TCK because you found some incompatibility between 2 or 3 implementations, you would view this significantly differently. You would view the standard as your hammer that you can use to pound in the nails that annoy you, where you don't have access to the TCK, and so therefore you only get the constrained side of it on a regular basis. And until we have fully open source TCKs, we're not going to get the full benefit of the standards. It's significantly better than having no standard at all. But when we have fully open TCKs, then you'll actually be able to hold your implementations accountable for their incompatibilities, which would be a very big addition to our industry. Okay, so here's some typical standards FUD that I hear. I hear getting left behind all the time. When is EE getting left behind? Let me ensure you that standards are there so that you don't get left behind. So who's using Angular or has used Angular or heard of Angular? We should get all the hands at that, the last part. So who heard that Angular 2.0 is going to be not compatible with Angular 1.0? Yeah, that's pretty awesome. When you think about how much money they have spent making Angular, and then you think about how much money the industry spent adopting Angular, that's 2 very different numbers. Like one is about that much, and the other one is about right up there. And for that group to just decide to say, we don't care about everybody who's been using this over the last couple of years, we're going to go a new route, it's very expensive for the industry to have to make these changes. Standards are there so that you don't get put into that situation, that you don't spend a lot of money and years adopting something and then it changes on you for very frivolous reasons the next version and your apps no longer work. That's what standards are for, so that you have some ability to have some stability there. The other one I hear is innovate, and this one is the one that really annoys me. They say, JavaEE isn't innovating. No, it's not supposed to be innovating. It's a standard. Standards are not supposed to guess. Standards are supposed to basically take the best proven technologies in the industry and standardize them so that they become permanent. We don't want JavaEE guessing about what you might need. That's when we end up things like CMP and JAX-RPC. That's what happens when we guess. It's not good. When we know, we end up with things like JPA and JAX-RS because they're proven in the industry, and then we adopt them. And the interesting thing that happened with JPA, for example, is it obviously was very closely modeled after Hibernate, but there were like 2 or 3 other pieces of software in the industry that were very similar. So we had Kodo, which became OpenJPA, and TopLink, which became EclipseLink. And so they were doing very similar things with persistence, but just slightly differently, like the Angular thing. And so when JPA came to be a standard, they were able to shift their implementation slightly to implement that standard, and now you have 3 choices rather than just the one. It's a total win for you, and it's a total win for the vendors, and it makes a stronger market. That's a success story for standards. That's what we should be doing. We should be taking things that are proven and then standardizing. That often means that we're not on the cutting edge in terms of technology. Vendors are still allowed to put cutting edge technology into their platform, and when it's proven out with the people who use it, yeah, we'll put that stuff into the standard. The third one that gets me is portability. People say this thing all the time. They say, I had an app, and I tried to port it from server A to server B, and it wasn't perfectly easy, so therefore, standards suck. Portability is a sham. And to which I say this. Portability is a life raft, not a silver bullet. Don't expect it to be like magical, but expect it to be at least possible. You won't have to throw away all of your code. Like imagine if you were working with a database and everybody used a different SQL syntax to a very significant degree, and then you wanted to migrate your data. You'd have to do a lot of work. Databases aren't completely compatible with each other, but they're at least compatible enough that if you wanted to make a change, it's within the realm of possibility. And so I think the expectation level of portability story has to be accurate. It has to be, your main ship is the big one, and if that starts to sink, everyone's got a pile on the life raft, and not everybody might get on the life raft, but at least somebody will survive. Some of the code that you've written will survive. Okay, so let's get into some actually codey stuff again. So CDI, who's heard of CDI? All right, we'll skip that one. I will say that the significant thing that CDI added is not dependency injection. It's for the very first time in EE, you had the ability to affect the container at startup and add things dynamically into the platform. This is a very big change for EE, and one that we're taking advantage of more and more. Before that, everything was declarative, and when the code was compiled, all the decisions were made. And now there's a life cycle that happens at startup with CDI, and you can add things dynamically, and that is a very significant shift than what was happening before. And you can add them programmatically, and you don't have to use annotations or XML as your way to describe what you want to happen in the container. You can actually add all these things via a being building sort of API, which is a lot like Spring Application Context, for example. It's where we're getting all sorts of extensions like Delta Spike into the platform, because it's now possible to do all these types of things and augment other people's applications by just giving them extensions to put into their application. It's a very significant shift because this did not exist in the 12 years prior. Archillion. Who's heard of Archillion? Awesome. Okay. So I will just briefly show it. I think I have it. Come on. There we go. So Archillion is a testing framework, and I think this example doesn't run, but let me. Yeah, I do have one that does. I'm just going to grab it. Okay. Here's a simple project. So we have a basic project here, that nice florid CPU. I have the old Relic 17-inch. I just can't seem to get one of those 15s. I wish they made them in 17 dimensions, 17 size, 17 inches. All right. So quickly, Archillion is a JUnit extension. And so basically, it will boot the server up, deploy the application, run your tests, undeploy the application, and shut the server down. So the significant thing about this is that we are constantly hearing how hard it is to test EE and things like that. These problems are getting solved and are now solved. So what we're doing here is we're actually building the WAR file up dynamically in the test case. And then once that is deployed, we will end up with the URL of the web app injected into our test case. And this is the awesome thing about this, is that we don't have to have ports and host names and paths hard-coded into our application. The only paths that we care about are the ones inside the application, not the ones on the outside of the application. And so this makes it significantly easier to change your test cases or to make them actually run against another server. So I'm just going to go ahead and run this. Okay, so that ran. And the interesting thing is that there are many different adapters for servers. Most of us vendors have an embedded version of our adapter and a standalone version of our adapter. So if you want to run with a remote process, you can do that. If you want to run with everything embedded into the JVM, as in a JavaEE fashion, you can do that as well. So if I put a breakpoint on here, and I go ahead and run my test with debug, it should hit my breakpoint. There we go. So now I can actually see variables inside the code, and I can actually do plain JavaEE style development, which is a very, very big win. I mean, personally, I would pull my hair out if I actually had to write my app, deploy it into my server with remote debug enabled, and then I can't step from the client into the server all the time. You know, you step over here, and then it's like you got to flip to another window, and you step over there. That's completely bonkers. So embedded containers with Archillion is bliss. All right. Some highlights. It's about 5 years old now, 200 plus contributors. The interesting thing about it is it's used in 2 TCKs, so it's not going anywhere anytime soon. There have been attempts at this in the past, such as Cargo. The problem is these projects run out of steam because it's a lot of work to keep the adapters that are around these servers that plug them into the framework. It's a lot of work to keep them updated. So the fact is that now it's a requirement. The CDI, TCK, and bean validation TCKs are written in Archillion, so therefore the vendors themselves have to pass those tests in order to be considered finished. So that means they have to support their Archillion adapters forever, which is good news for you. So I have an interesting comment to make. I personally think that the appropriate ratio of tests to runtime code is about 70% test to about 30% runtime code. You have a lot of exit paths and entry paths, so that makes the amount that you have to test significantly higher. If that's true, what is the greater portability concern, the runtime or the tests? Obviously the tests. So the fact that you have a testing framework that allows you to migrate from one vendor to another is perhaps even more significant than all the hard work we're doing in the standards themselves. I wouldn't say quite like that. Obviously, we have to have the first in order to have the second. But really, it's valuable to have portability in your tests. If you are binding yourself entirely to the server that you're working on with the tests, you're not going to get much portability unless you one day just up and throw away all your test code. All right, so there's some fun things that we have. So here's a little fun one. So who's heard of Spring Data? Okay. So I have an example. I have the out-of-the-box Spring Data example. Okay. So the concept is you have an interface, and it's got a CRUD repository, and it's got the entity type and the primary key. And then you have these methods that go find this, find that, find by first name or last name. And if we want, we can just run this on my old laptop here. Okay, come on. There we go. So that ran in about 6 seconds. So I decided to make a completely more awesome version of Spring Data. I'm going to show it to you. I call it Simple Data. The name is very inspired. Okay. And so instead of a simple user repository that extends CRUD repository that has finder methods in it, what I do instead is I have a simple user repository that extends CRUD repository and has finder methods in it. And I've got my user, and then I have my test case over here. And if I go ahead and run that test case, oh, come on. Jar file missing. I'll have to run it from the command line and see what happened here. I didn't sacrifice enough chickens to the demo gods, apparently. Okay. All right, well, let's see. Did that run from Maven at least? Not running at all. Okay. All right, well, I was going to give Spring some props here. So this version, which I don't know what is the problem, jar manifest missing. Oh, okay, we messed up my Maven dependency here. I don't have the dependencies that I need. Thank you, Maven. Okay. This version that I have, if you watch a previous video, runs in the same time as the Spring one. And the joke is that this implementation, the simple data, is actually an EJB home interface from CMP 2.0. And the comment that is not that Spring Data is unoriginal or bad, I think there's really a different commentary to be made on technology as a whole. I think that there are some lessons in time that we have to learn from certain ideas that we've tried. So a friend of mine has a quote that he says all the time, and I think it's very, very true, which is, a good idea at the wrong time is tantamount to a bad idea. If you're trying something and the market's not there or not ready, or the tools are not ready, it's not going to work out. You know, a lot of people tried to do the iPod before the iPod was the iPod, right? But it was just not, the technology wasn't there. The second comment to be made is that a lot of the things that we tried early on failed because we lacked the right tools to do them. So the only thing that we had to do CMP entity beans, and I didn't show you the cruft that mine actually only runs because of this heap of XML that I didn't show you. Yeah, this is why CMP failed. It's because you actually had to maintain this mapping between your code and the queries all the time. And with Spring Data, you can put the queries right there in an annotation on the interface. That's really the major difference. And so a lot of the ideas that we tried failed because we didn't have the right tools to execute them. So that's a very a significant thing. We didn't have annotations when we tried to do CMP. It didn't work out so well. No one wants to maintain all this heaps and heaps of XML with queries in it that references our methods, and every time we rename them or rename the class, all of it breaks. And so that's a very big problem. And so now that we have annotations, we didn't actually try something like home interfaces again because we were just too chicken. We had gotten beaten up too much in the market for this ugly thing CMP. So when we made JPA, we asked ourselves the question in the expert group, do we want to do like an easy sort of way for people to not have to write all these query things all the time? And basically, we kind of unanimously said, yeah, people will just look at it and they'll see CMP and they won't like any of this stuff, so we're just not going to do that. And so we didn't do it. We're still not doing it. And then so eventually, people get sick of writing all this redundant entity manager access stuff. And the first thing that happens, the very group that beat us up over CMP made the thing that we were too chicken to reintroduce. And so I think that's a good thing. We need that in the market. So the third lesson is when the tools change, you have to retry old ideas. An idea that failed is not permanently failed. It just means you couldn't do it with the tools that you had. When new tools become available, give it another shot because you might achieve a different result. Which is why a lot of technologies look like the old previous technologies we've tried before, but sometimes they succeed because sometimes there's a new thing that was added to the market that makes an old idea possible again. Virtualization, obviously with Docker, is kind of like a rebirth, and it's making more traction than it made the previous 5 years. And then also never confuse ideas with execution. Just because an idea failed in one person's hands doesn't mean it can't succeed in another person's hands. So that's the high level. I'm going to skip the security thing. This is an old slide. There is an EE security spec. It is going quite well. I would encourage people to get involved with it. The spec lead is pretty awesome and open to very great ideas, and the expert group is pretty diverse. And EE security is the worst part of the platform. Who uses EE security? Okay, yeah, the Jax RPC, the hardcore guy in the audience. Yeah, so we're trying to fix that, and so one of the things that we're thinking of doing is just basically making it easier for you to implement the security logic. Tell us here, here's the username and password we were given. Why don't you tell us who that is and what roles, and then we'll actually carry that information through, and you can use @roles_allowed standardly. Certain things like that are ideas that are being kicked around, as well as ideas on maybe making it possible for you to standardly add users to your platform. That might be kind of nice. So certain things like that are being discussed. This is a really cool one. JMS is going to get revamped. Come on, there we go. So Okay. Here's what we currently have for a JMS message listener. We have this. And basically, this is the best we have. We have an activation config at the top, which is basically a hash map. And we have loosely typed name values. And you have to look up in the documentation to see which ones are available. You have to look up in the documentation to see what parameters are acceptable. And this is, to me, is just a very terrible waste of an annotation. An annotation is, supposed to be strongly typed. This should actually have a max messages per session, actual attribute with an int as a parameter. Then you know what the acceptable data type is, and the code does not even compile if you don't have it fully enabled. So this is what we were doing. Happy birthday, Jean-Louis. This is what we were doing, and what we are doing currently with JMS Messenger of Beans. Here is what is coming in JMS 2.0, or 2.1, I should say. Didn't come in 2.0, but will be in 2.1. Basically, something like this. Hallelujah, at last, finally. Basically, what we're doing here is we're allowing the connector who drives the MDB relationship to actually see the bean and inspect the annotations on it, and it can take all the metadata from a strongly typed version of it rather than through this little properties thing at the top. In the past, that was the only thing that the connector could see. We changed this in EE7 so that the connector can now see the bean itself and can see all the annotations on the bean, so that allows annotations to be passed from one side of the fence to the other, which was previously impossible. And so now you can basically do this, or this will be what JMS looks like in the Java 8 timeframe, JavaEE 8. There's also some interesting commentary to be made about how Java 8 syntax might improve the platform. So here's an example of, let me see if I can find the good one. Okay, so here we have something that uses the @schedule annotation and annotations at the top. And basically, this bean executes at springtime for planting and at fall to harvest. And it probably takes you a moment to check out this code. The schedule methods version of this. All right, let me see. Okay, here's the way to do the same thing using the logic at runtime rather than declaratively. So the previous one used annotations that were hard-coded and compiled in, and this one uses the timer dynamically. The problem is that this API is very crippled by the fact that we can't pass good information about what we want to have executed. So whereas the other one had annotations on the methods called planting corn, harvest corn, this one, with the API that we actually have to pass in this state object and say, when this date occurs and timer occurs, fire this state object. And then we actually have to do something crazy like what state object was given to us, and then what method do we want to then invoke. This is begging for some improvement with the Java 8 syntax. Basically, with Java 8 syntax, hold on. There we go. We should be able to do it like this. Instead of passing in a state object, pass a method reference. At this time, here's the method I'd want you to invoke. Go ahead and invoke it. And so these are the types of things that we could do now with Java 8 in EE8. And I think that there's a significant opportunity in front of us. The interesting observations to make here are that annotations are a declarative approach to programming. And if we had the ability to more dynamically decorate the logic that we want by saying, I'm going to build up the rules and I'm going to pass in the method, rather than having the method here and the annotations statically on it compiled in, we have the opportunity to shift from a declarative-based programming to more of a runtime-based decision-making. And that's a very significant change. So that means we have the opportunity to see more runtime-based APIs taking advantage of things like method references. I also think that interceptors might become slightly less important. We had discussions when we made the @asynchronous annotation in EJB. Do we want the client to be able to decide when the methods should be asynchronous, or is it natural that only the server side or the component side gets to make that decision? We couldn't find a good way to do that for the client to make that decision. But if you actually were able to pass the method reference into your async thing, you could actually have the client make that decision. You could have an async method that took a function, and then the client could make the decision on when they wanted something to be asynchronous or not. So I like to look at it like this. We have 3 eras of JavaEE. We have the XML era, where that was the only tool we had, and we had things like CMP in that era. We had the annotation era, which is the JPA era, and annotations started in 2006, but it wasn't actually until the next major spec revision, EE6, where annotations became widely used. Now we have another language revolution, Java 8, and now we have our first spec round to take advantage of those features. And we also have a new and completely open JCP, which we didn't have before. So with these 2 things together, we actually have a significant opportunity to reinvent the wheel in a lot of regards, to change the way our APIs work, and to have all this happen openly with all of you involved in the process. And so if we don't like what EE looks like in 5 years, we have no one to complain to other than ourselves. So I would say play an active role and be a game changer. The biggest game changer in JavaEE is right here in this room. So thank you very much, and please do get involved in the standards.